Hey folks, Jonathan here. Back working on the motorcycle engine a little bit here in the evening. I got my bushing made, but I screwed it up, and it's not press fit. And I made this out of an old pilot bushing for a Chevrolet, and I meant to do a press fit, and I just screwed up. So that's the good part about having machines but not being a machinist. You know, if you screw up, it's because I'm not a machinist. But anyway, they're cheap. I can come up with another one here, and we'll get it right. But anyway, this is enough right here that we can put the piston on and get us an exact height. So we're still gonna be able to do what we need to do, but I'll make another pin. And here's a little closer look at the cylinder for anybody that didn't see it. It's got the rockers and the adjusters with it. It's in fair shape. I mean, it had a little wear and stuff, and that's why I went oversized with the piston. And it looks like the threads are good. Everything seems to be pretty good shape. Now this does come apart. This is an aluminum head with a steel cylinder. I think it unscrews apart, and I'm going to try to keep from taking it apart. And it'd probably be easier if I did, but you know, I've still got to do the same stuff. I still got to check the CCs on it and everything, and we'll get it all cleaned up. And here's the other one that I bought with it. And I actually bought them at 2 different times, but this is another one just like it. And it's missing the adjuster for the valve, but that wouldn't be hard to make. And the reason I went ahead and bought the other one is because we're going to do a foundry mold for that crankcase, and we just as well go on and cast 2 of them. You know, it's not much harder when we're doing it. We'll go ahead and cast 2, and then maybe I can find somebody that's interested in the jug and the castings, or maybe I'll put it together later. But you know, they can go by this video and should be able to figure it out. And if I make any mistakes, well, I've already made mistakes, but if I make any more mistakes, maybe somebody can learn from mine when they're building theirs. But anyway, we get back at it, and we need to do the CCs on the cylinder, and gotta find a plug that'll fit in an old 18mm. I've got them around here somewhere. But all right, show you more. Okay, I want to show you something else here real quick. This cylinder's been honed on a little bit, not much, but just a little bit. I don't know if we can get it where you can probably see the cross hatches and stuff. And I think this thing is set with probably a little bit of water in it. But the reason I ordered this oversized, now it's been honed enough to where my piston is going in, but we've got to figure out a clearance. And you know, most automotives about 2,000s. Now I tractor pulled, so we done 5,000s to keep down on the friction. And I may do 4 or 5 on this, and it's a little more wear, or a little more than you'd want on a car. But my fear on this, it's a pretty thin cylinder wall, and it's air cooled. If it starts getting hot and that piston expands, especially with that piston being aluminum, you know, it's going to gall to the cylinder, and the last thing we want to do is build it too tight. So we'll actually we'll check this, and we'll see what we've got, and you know, hone it and work with it. Now you want to check bottom, top, center, make sure that you're not cone shaping it or hourglass shaping or something like that. But I think it's gonna be all right. We'll get the valves pulled out of it and go ahead and check the seats and stuff on it too. But so far so good. Got to get the CCs done here so I can start actually drawing out my plan for my block. Okay, we're getting ready to check our CCs. The only bad thing is the only syringe I can find was that's an old animal syringe, but it's only 3 milliliters, so 10 times would be 30 cc's. So we're gonna fill it up, and I'll show you where the level's at in it. I'm gonna try to get some light to where you can see down in it. But anyway, show you in a minute. Okay, folks, I don't know if you can see this, but 39 cc's is what I've got in it, and it's just taking up our chamber, and it's actually let me see how water don't lay flat. It's kind of crazy, but it sticks up a little bit. And but anyway, this is I guess it's good, and it's not a problem, because what we're going to do we're going to figure out how we can space this piston just off the top of the cylinder, and got to allow for expansion. But we'll probably just put something up there, put the piston all the way up against it, and that'll give us a good measurement, and I won't have to measure from the bottom. And you know, we want as much compression as we can get, but you know, an engine will run on 4-to-1 compression with no problem. And you know, a lot of the old tractors that burn kerosene, they run on 4-to-1, and then you'd preheat the kerosene and there's diesel and put in it, and our tractor vaporizing oil, which is TVO, and some call it distillants, but you would heat it through the manifold, and they actually called it, instead of a carburetor, it was a vaporizer, and it would run on it with a spark ignition, you know, at 4-to-1 compression. So you know, we're going to try to keep it up as high as we can get it, and with the little extra stroke, it's going to help us out. But I think we're going to be just fine. But I think I'll take something. I think we'll probably go about 30 thousandths, maybe 20 thousandths off of the top, and we'll cut us a sheet or something and lay in there on top of the head, and then let the piston come right up against it, and then that'll give us our measurement down to the center of where we want the crankshaft at. So, all right, we're going to get this water out of here and get this thing cleaned up. The good part is the valves are seating really good because there's no water at all coming. You know, no water dripping out whatsoever of the intake or the exhaust. So we're good to go there. But yeah, that gave us a good idea of what we need to do. And you know, our final compression's probably, you know, we're going to be able to get close to our 7.8-to-1. So I think we'll be okay. All right, show you more. Okay, folks, we've got this new piston here, and I'm going to try to show you exactly how much cc's are in these valve reliefs. And I don't know if you'll be able to see this or not. Maybe we can get it to focus in. Well, anyway, we've got exactly 2 cc's in this syringe, and I'm gonna try to put some water on it, and you'll see what I'm talking about the way water actually puddles up. You know, it don't lay flat, and we're gonna see how much we can get in it. We're right at 2. And we put in a 1/2 cc, and you can see how it is, but now it's lumped up some. So that's what I was talking about. You know, if you go to try to flatten it, you know, you see it spread out. So that was less than 1/2 cc on that one, and this one's smaller. So these are not going to affect us much at all. So we're going to get something to shim it, probably 30 thousandths. And you know, there's no head gasket, so we're not worried about anything there. But we'll shim the piston 30 thousandths off of the head, and then we'll put this back on the crankshaft, and we'll be able to check and see how far the crankshaft is. Let me back up. We'll be able to see how far the crankshaft actually is from this base, and the center of the crank to this base, and then we'll be able to work from there. Now you can see there's a cutout in here. This is not a brake. Now this is for clearance for a rod, and you know, we may have to clearance it more, we may not have to. We got a little bit more stroke, but we got a different piston height, so you know, we'll figure that out as we go. Not a big deal. And you know, you don't want the rod to come over and slap the side of the cylinder. And the way that we're going to do it, this, where you can see the valves, is going to be the side of the cylinder, so if it hits, it's going to be hitting there and there. So all right, I'll show you more. Okay, folks, what I ended up doing here, I've got it set up, but I took a piece of copper, and this is actually right at 35 thousandths thick. So yeah, it's right at 35, and we've got this set up, and I put the piece of copper, I just cut a round blank out, and I put the piece of copper on top of the piston, you know, and ran it all the way up, and this is what we ended up with. And we don't have a lot of space between here, but you know, 100 thousandths is you know, a half mile. It don't really matter. But what we're going to do, we're going to get a measurement from here to the deck, and then of the cylinder, and then we'll measure this and split it in half, and that'll give us our exact center of our crankshaft, and then we can start drawing our diagram up for this. And you know, I'm going to of course cast it tall and machine it down, so you know, we've got to make sure we've got enough meat in it and built right to be able to work. I don't like the fact that this crank is so narrow in comparison to the jug. The bearing's going to be here, and the problem with that is, you know, by the time you get to the outside, you're not quite to the outside edge, so we're going to have to bump it out some. I don't want to get it too wide out because I've got to have room on the crankshaft. This side here is going to have a gear. I'll show you what I'm doing here. This will help give you an idea, but this side will have a gear which is 18 tooth, and this is our 36 tooth Briggs gear, and we'll have one mounted here, and then we'll have one mounted over here. And what we'll do, they'll be on a pin, probably bushed. I may end up bushing them. They wasn't bushed from the factory, but we may do that with a bronze bushing or something. We'll see. There's a lot of side pressure on this, so I may not do it. But we're going to have to do that. I'm going to figure out what I'm going to do on the outside here for oiling. I may set this up with an oiler on it, maybe a drip oiler or something like that. But anyway, our gear will be running here, our bearing will be running here, this will be running on one side, and then we'll have another one right here and on the other side, and we'll either run this gear, both of them, off the big or the small gear, or we can run this one, you know, up to the big gear and then this one to it. Now it don't matter which way it rotates, it all matters is what, you know, if you got it in time or not. So rotation's not important on this, and it should work out. We'll make a cage for this, and it'll have lifters, and you know, we could run it like that, but we're going to run into space for our push rod to come up through, and because our gear is going to be down, so it's probably going to be just like that. And you know, we're gonna do away with all this up here, if you can see it here. We'll do away with all this up here and just have open push rods, so you know, if they're angled a little bit, it's not going to hurt. I've actually seen one engine that had them crisscrossed, and what they done is they had a one cam gear, and they had a lobe here and a lobe on the outside, and they actually had one running up this way and then one running the other way, and it looked like they was actually crisscrossed, but two lobes off the same gear. And it really don't matter, you know, as long as you're, you know, not putting too much side pressure on it. And you know, they fit up inside of balls here, you know, it's a sort of a ball socket. So but we've got this where we want it. I just got to set it up on the table here, and we'll get our measurement, and that'll get the start for the for building the crankcase. I may go bigger with the crankcase, make it lower, and this will not be centered in the case itself. And the difference with that is whether I'm going to be able to do it on the lathe or not. I'm not going to be able to do it on the lathe if I don't make this, you know, perfect with the center hole. But I mean, I can still do it on the milling machine, and you know, with a boring bar. And we may make it longer, and that'll make it look a little better, because we don't need a little short, tiny case and a, you know, a tall jug. And I think it would look a lot better if we came down some, and crankshaft to be off center. It'll just be up high a little bit, but that won't be a problem. But we're going to get the measurements. I got me a piece of paper, and we'll start writing down some measurements on it, and that way we can figure out what we need to do on our casting mold or foundry mold, and we'll get to building on it. Okay, I got a lot of the measurements that I need. I was looking for stuff just to lay on here to get an idea of the height and what it was going to look like, and size wise. And it's probably kind of hard to tell on the camera, but it looks like I'm not going to have to go really big. I was thinking this blade here, it's an old chop saw blade. It's a good size. You know, it makes the jug look like it's, you know, supposed to be with the bottom. I mean, I don't want to make it look like it's huge on top and small on bottom. So we'll probably do this, and it'll end up getting, of course, getting cut across, and you know, not cut on this, but you know what I'm saying. There'll be a flat spot on the top where this mounts. So I've got all the height measurements. And what I'm gonna do is draw this out on poster board, and we're gonna make a full-size template, just like I want it. I was gonna do just one foundry mold and flip it and, you know, use it for the backside, and then just made them up, but I want to make them a little different. You know, one side's going to actually have the cam carrier, and the other side's going to be running the pulley to drive the bike. So we're going to make two separate ones, and a little bit of a, you know, time-wise is a pain, but I think in the long run it's going to actually save me time and trouble. But anyway, I'm going to end this one, and the next one we should be hopefully building some foundry molds, and I'm probably going to use mahogany if I can find some, because I mean that's what I usually use. They holds up good, and it's not real hard to work with, and you know, you don't want to use anything really hard. And then we'll do some Bondo work on it, and you know, get it the reliefs right on it, get it painted, and that way it'll hold up and be smooth. And you know, I'm not a woodworker, so we'll just have to work with it. But anyway, all right, appreciate you watching. Bye.